you. Okay, welcome everyone. My name is Yoonjin Yoon, and I'm the Faculty Director of the Urban at KAIST, which is the KAIST Initiative on Urban Science. As always, we'll spend around 20 to 25 minutes for talk and around 10 to 15 minutes for Q&A. And you can use the chat box in the Zoom to upload your question anytime during the talk. So today, I'm really happy and proud to introduce my colleague, Professor Jihee Kim. Jihee is Stanford-trained economist and now teaches in School of Business and Technology Management in KAIST. Please welcome Professor Jihee Kim.
Hi, everyone. Thank you for having me today. It's great to be here. As Professor Yoonjin Yoon just introduced me, I'm an economist here, and my focus of study is economic growth and inequality. But the work I'm going to present today is a little bit different. It's about measurement, which should be done before we study any growth and inequality. So this has been a very highly interdisciplinary work. So it's been in collaboration with School of Computing here, Computer Science Department here. So I'm gonna introduce the entire team later on. So let me first start with sharing my screen. But before that, I don't know how many of you have actually noticed my background. So I always do this. Do you know where this area is? This is actually satellite images of New York City, some part of New York City, covering NYU campus. So our idea, what the work I'm going to present today is actually when you look at these satellite images, the idea is can we measure how much this area is developed just looking at these images. Like if you're given another satellite images of city of Boston, can you say that New York City looks more developed than the city of Boston? Or if you have more detailed satellite images, like can you say that this block in this specific block in the New York City, can we say that this is more advanced, that more developed than the neighboring blocks? Can we come up with a model that tells you that? So that was our problem that we wanted to solve. So let me just start sharing my screen. Okay, so we have this problem that we wanted to solve. Just by looking at the satellite images, can we measure any economic status of that region? So for the solution, we came up with a human-machine collaboration model. And using this model, we applied to the region where there's very few economic data that's disclosed, that's open to the world, which is North Korea, as you see here. So we applied our model to kind of see in very detailed way, in very granular way, can we figure out the economic development level in North Korea in every corner. So that's our problem. So just repeating myself, we wanted to measure economic development at a very fine grain level in a region where there's very few socioeconomic data to begin with. So we use daytime satellite images and machine learning, and we only require very lightweight human input. And we applied to North Korea, and we created this first ever grid level economic map of the entire North Korea. So each grid has it's 2.5 kilometer by 2.5 kilometer. And for each grid, it has a number, the number representing the level of economic development in that region. And we also test this model, not just North Korea, but for other low-income, underdeveloped countries in Southeast Asian countries. So the work I'm presenting today is the technical part is published in like 3 years ago in a computer science conference. And our application to the North Korea, it's actually published a couple of weeks ago. So I'm really super excited to present this work after publication. It's published at Nature Communications. Um, okay, so let me now introduce my team. Professor Myung Ta here at School of Computing, she's leading our team. She is in charge of our technical part. And we have three economists, including me. Professor Sang-Hyun Park is from HKUST, and Professor Hyun Ji-yang is at Sogang University. And our students team are the greatest. These like Donghyun, Sangwan, these another Sangwan. These are our technical brains, and Jaesuk here is our geographer, and we have other amazing students in our team. See. So let me just begin more of the background of our work. So I think you guys all know that measurement is essential, but I mean, you need to measure something to do anything, any policy design or evaluation, just to do anything, you need measurement to begin with. Without measurement, the knowledge is meaningless. But the problem is economic measurements, once you think about it, it's very costly. It requires a lot of money and human resources, and time-wise, it's every aspect it's expensive. Like think about census. Like large number of people, they have to visit every household, and in every household, um, the respondents they have to answer a very long list of questions. Like time-wise, money-wise, it's very expensive. So just to complement, not replace, but just to complement this very expensive economic measurement, there are some researchers, they came up with this idea, why don't we use satellite images with machine learning to measure those any economic status of some regions? Because it provides some potential to like generate very consistent measurement because once you have images and all those satellites, they're gonna take pictures in a very consistent manner, hopefully. And because they are gonna take these photos anyway, it's cost saving as well. But the problem is, so this work is So this work is the first ever groundbreaking work applying machine learning to the satellite images and also using nighttime uh, satellite images as well. And using survey data, they try to estimate household consumption and assets in African villages. But the problem is they require the survey data to begin with. But the problem is many regions in the world, they don't have high quality survey data to apply these models. It's not just in North Korea, it's this problem, the lack of survey data or lack of any kind of data is very prevalent in many, many poor countries because they require like expensive resources. And the extreme example is obviously North Korea. The latest population census of North Korea was done by UN in 2008. And nowadays people use mobile or internet traffic data or like credit card transaction data. So for North Korea, we cannot think of this data. So the conventional ways of collecting the North Korean data was through interviews with North Korean defectors, like or analyzing through North Korean newspapers, or using aerial images to identify objects. So, so this was our problem. So our task here, we define our task here, how can we measure economic development at a more fine-grained level, not just the country level, like GDP, like, not like that, but at a more fine-grained level, without any economic data to begin with. So we came up with this model, the human machine collaboration model in 2020. Our idea was the novelty in our idea was just change the problem statement a little bit. So instead of directly targeting to measure, for example, consumption, how many dollars that these people in these regions consuming or how much they're producing. Like instead of targeting this absolute level, we change the problem. We change our question to the relativity questions. So why don't we just, because we don't have data to begin with, why don't we just rank those images by economic criteria? For example, by urban development level or just economic development level. Or we haven't done it, but we can do like by population density. So like given any economic criteria, why don't we train a machine to rank satellite images? So to train these models, we only need relative scores, not the absolute level of consumption or population. We don't really need this data. So our AI human collaboration model, they takes in human inputs in a form of relative scores. But we don't need relative scores for every image, but for a finite set of clustered images. So let me just explain in detail how our model works. And please interrupt if you have any questions. Okay, so our model works in three or four steps. So, okay. So before we apply our model to North Korea, where there's no data, we wanted to test a model where there's some data or where there's rich data so that we can test our model. So we started with South Korea, where there is rich data set. For rich data set, meaning we need not for training purpose, but for evaluation purpose, we need the data at this very granular, fine-grained grid level. So for South Korea, we had that data for population density and also other measures. So we start with South Korea to just evaluate our model, and once we are sure of our model's performance in these data-rich regions, we're going to apply this to North Korea. So that's how we're going to go. So first, we have this we collected the South Korean images and we lightly label them. So we only use three labels. First kind of labels is label those images as urban images or rural images or uninhabited images. Just three labels. So this type of labeling is really easy, and we did this for only 1,000 images. And using this, in the next step, we ran a clustering algorithm where this clustering algorithm kind of groups images into some similar looking images. So there's in more technical detail is this, but I'm gonna skip the details because we don't have much time. Is this. So this is the clustering results. So, this. As you can see, this is so for South Korea, we asked our clustering algorithm to generate 21 clusters as this one uninhabited cluster and 10 rural clusters and 10 urban clusters. And this is an example of showing those clusters. Cluster number 1, cluster number 6, and cluster number 17. And you can see that the clustering algorithm did a pretty good job. They look very similar. As you can see, the cluster number 6 looks very densely populated with all these buildings. And this looks like this doesn't look much like residential area, but then this is like the farming area. So they did a pretty good job. So we grouped those images into 21 clusters for South Korea. And then we move on to the next step, which is a very crucial step, where this is where humans come in. Using those 21 clusters, what we did is we sort these clusters by some economic criteria. So what we did for South Korea is we recruited, I don't remember exact number, 5 or 6 experts. Experts meaning experts who's familiar with those looking at satellite images, or economists who's know where the production, who knows where production comes, um, like those experts. So we recruited these experts and asked them to sort or order these um, 21 clusters by level of economic development or level of urban development. So this shows one example. This box is one example of the results. So what this says is, for this specific expert, this person thinks cluster 2, 3, and 7, these clusters look the most developed. But between them, this person's not really sure. They look very similar to them. So that's good. But then the next one is cluster 10. Cluster 10 is the next. And although this person doesn't know the ranks between 2, 3, and 7, this person was sure that the cluster 2, 3, and 7 looks more developed than cluster 10. And next is cluster 4 and 6, and 1, 5, 8, and continues. So this we call this a partial order graph, or POG. This is the human input. And if you're given, so you're given the images in these 21 clusters, and you're asked to rank these clusters by level of economic development. So the average time these experts took is like 1 to 2 hours. So it's a very lightweight labeling, considering the amount of satellite images that we have. So this is called human-guided partial order graph. And also, the partial order graph can be created by data as well. So if we have data, so if we don't have data, we can ask humans to do it. Or if we do have data, data can do it as well. If we have existing economic stats by the grid level, so based on this data, we can create a POG. Or nightlight data, we can create a partial order graph using nightlight data. So later on, we're gonna evaluate which POG performed better in predicting the level of economic development. Okay. Once we have a POG to start with, we move on to the next step. Before we do that, sorry, I have to emphasize this. Because expert in for the human guided POG, because they rank these images only by looking at the images, what these ranks represent. We have to be really careful when interpreting these ranks, is the images are the only source of evaluation, only only materials for evaluation. So its interpretation is like this: physically visible urban capital stock, or physically visible urban development stock. So that's like more detailed interpretation in this specific case. So let me move on. So once we have this POG, so POG delivers the relative ranks of those clusters by some economic criteria. Then what this step C does is that machines, it's called, more technical terminology is metric learning. So what they do is they learn to rank these images that preserve the order given in the POG. So that's what this metric learning step does. So what they do is, for each grid, they allocate some number that will preserve the order of the POG. So once everything is done, we get this relative economic scores, which we call the C-score. So that is how our model works. And then moving on, we wanted to evaluate our model, the performance of our model in South Korea. So we collected publicly available, freely available satellite images at the highest resolution that we could get um, at no cost is 4.8 meter resolution. What this means is one pixel is 4.8 meter by 4.8 meter. And this one image, we call it grid. This one grid has 256 pixels and 256 pixels. Okay? And one pixel is 4.8 meter by 4.8 meter. So that's the images that we are dealing with. And for the entire South Korea, there were almost 96,000 images. And for Vietnam, these many images, and Malawi had these many images. And so we created partial order graph by humans. And also we created a partial order graph by population density and also nightlight intensity. And this shows the performance. You can see that, so here, what is it's like, this was the best performing POG. So the evaluation criteria here we use as the measure of economic development is gross floor area. So what gross floor area means, it's actually the volume of a building. It's the width. What is the area that you see the building from the above? It's the area times the height, actually the volume, and summation of all these volumes of buildings in one image grid. So that's gross floor area. And this other measure is population density. So that could be a measure of economic development. And for the criteria, we use Spearman rank correlation, and Pearson correlation is the usual correlation that we use all the time. But Spearman correlation is the Spearman rank correlation, meaning whether if we rank those image grids by gross floor area, their rankings, and the rankings that's given by our score, how much they are correlated, how much the rankings by these two measures are correlated. So Spearman rank correlation is that. And you can see that the best performing POG shows the highest Spearman rank correlation. Because as I said, because our scores are for relative evaluation, Spearman rank correlation is we think is a better measure than Pearson correlation. And since it performs even better than data-driven POG performance. So we are pretty satisfied, and for the population measure, the number was pretty good. And this is a result for Vietnam and Malawi. The performance wasn't as good as the South Korean case, but I think we can improve more on this when we customize the model a little bit for these countries. Let me just skip this. And when we apply this to North Korea, so we did the same thing, but the free publicly available satellite images were a little bit more lower resolution than South Korea. So we use this. So the one pixel is 10 meter now. Before it is 4.8 meter, but now it's a lower resolution. We did the same as before, but what we did differently here is now we asked 10 experts and asked them to create their own POG. And then we came up with a way to kind of like aggregate these 10 experts rankings and created one unified POG. So we use that here. That's what we did differently here. And the rest of it is the same. So for the satellite images, we use we focus on these times from 2016 to 2019. So this is our final result. So we created this map of North Korea with all this grid level scores for each grid. Like they have number. You see that the red means more developed and blue is like not much developed. You can see that this mountainous area, they are not really developed. They are like uninhabited. And you can see that Pyongyang, as expected, Pyongyang is uh, the most developed. And you can see those port cities are developed. And you see Kaesong as well. And those border cities, Siniju and the Nasan is another port city. You can see those. And we also aggregated these numbers at the district level. Okay, so this is the map. And I show you one instance, one county case. This is Gangwon province and Seppo County. And you can see that this is the satellite images on your far left. You can see that this area is the most developed and it shows as the numbers here. And this is nightlight intensity. So nightlight, they did a good job um, um, identifying these regions, but for other area, there's no variation because there's not much nighttime activity going on in North Korea. And so this was an example. So for North Korea, although there's not much data, but we still wanted to evaluate our results. So we did our best to collect any types of data that we can utilize. So there's no official data, and there's nightlight intensity data, and it has been used in the literature, but it's available at a much bigger grid level. It's like 500 meter resolution, but we can still do the evaluation. For the further evaluation, we did the evaluation in two ways. The first is we evaluated our scores at the grid level and also at the district level. For the grid level, we use the data from the South Korean government, built up area data. The built up area is different from the gross floor area that we use for South Korea. So there's no height of buildings data for North Korea. We can only figure out the shape of the buildings when we look at those buildings from the above. But this is not a perfect measure, but still it's better than nothing. So we use built up area as the measure of economic development, and we're gonna evaluate our scores, how much our scores are correlated with built up area. And at the district level, there's a little bit more that we can utilize. The first is population density from the UN census. And also there's number of markets data, the market data. That's actually the markets are identified by manually looking at satellite images, and they were confirmed by North Korean defectors. We know, I mean, in Korean it's called 장마당. Um, so there's data set where they show where each 장마당 or each market is located and how much area this market is occupying and how many number of booths the market booths are there in each market. So we're going to utilize this data, thinking that this could be a measure of economic development. And also there's farm data that we can use, meaning so a great North Korean researchers, they went over the North Korean newspapers manually, and whenever a farm name comes up, they put it in a database. So they created this North Korean farm database, and we're gonna use how many firms are in each district as a measure of economic development. Um, so this is the result. First, when the built up area, looking at that as the level of economic development, this is our R square. This rho is Spearman rank correlation. So I think this is a good measure to evaluate our scores, um, which is pretty good because previous work of measuring any economic conditions using satellite images, their correlation was at this level. and using much higher resolution. But using much lower resolution and without any ground truth data, so we thought this is pretty impressive results. And thus, and now we are looking at comparing our scores at the district level. So before, so this was grade level evaluation. This is the only thing we could do at the grade level. And moving on to the district level, we were able to evaluate our scores based on population density. That's done by UN census, and also nightlight data. So the nightlight data, so this is like comparing the performance of our model to the performance of nightlight data. So nightlight data for North Korea, it's not a good measure of development. So our measure is doing much better. And the other model evaluation results at the district level, which is pretty good. And then, okay, and then, so I just wanted to share the result that we applied when we applied our model to other Southeast Asian regions. Oops. Oh, so the last thing that I want to share is what can we do using these measures? So we wanted to have at least one use case. Uh, so we want using our measure because our scores, we can create our scores for 2016 and 19. And some big events happened in North Korea during this period, which is sanctions. So since 2016, I mean, North Korea was under sanctions for a long time, but then this time was different. The the sanctions, economic sanctions, were really, really heavy, and it was just targeting many uh many corners of North Korean economy. So this was different. So we wanted to see how our numbers, how our measures were different between 2016 and 19. So so now this is a map for 2016. This is 2016 and 2019, and this shows you the change. These like red area is where it's more developed. There's like some growth showing, and others are like just like looks like zero. So average of the changes in the grade level scores, the total doesn't really look that much different. But then if you divide the North Korea into the rural area and urban area, you see some differences. You can see that before and after sanctions, the development is more concentrated in the urban area and more in top 10 cities. Just to see this in more detail, we ran economic regressions. So there's an economic regression tables. What it shows you is, I'm gonna just give you interpretation. Whether the area is farther from Pyongyang, it's less developed when you compare 2016 to 19. And when it's farther from the nearest city, it's less developed. And also there are these 4 kinds of economic development zone that's been promoted by Kim Jong-un, 4 different kinds. But out of these 4 kinds, these agricultural development special zone and tourist like special development zone, they were more developed between this time. And I think what's most interesting is this: the area where there's uranium mine, you see more development. I mean, it's very suggestive, so I don't want to make a very strong statement out of this, but it seems like after sanctions, maybe they were really limited resource setting. In this limited setting, they allocated more resources to those, I don't know, uranium mines. Okay. Then and this was showing how the one example of tourism project kind of developed. You can see this just looking at satellite images, and it shows up in our numbers as well. and not much going on in the industrial project. So to use I'm using a lot of time. So there's so much that we need to do to improve our model and scores and everything. It's just it's been 5 years since we started this project, but we think there's so much to be done to provide robust and consistent measures. So we definitely need more studies. I'm gonna just skim my detail here, and there's some limitations as well. But I'm gonna just summarize. So we came up with this AI human collaboration model that does not require much of the existing economic stats to use as ground truth, the data that we use to train our AI model. And we did a pretty good job when we applied this to North Korea. And when applied to North Korea, we were able to see where it's more developed or less developed when we compare before and after sanctions. Um, so I guess it our model provides cost saving way and scalable as well, because it can be done when you have images and very lightweight expert inputs. It's scalable in that sense. We provide a scalable way of economic measurement, and we see potential, the great potential to utilize our model and scores for underdeveloped or developing countries where they don't really have much resources for conducting traditional economic surveys. Um, so we're still working on to improve these in many different dimensions. And right now we are looking for applications to urban problems or environmental problems or any like development project or any development aid project where our measures can help developing or evaluating any policies uh, like that. Okay, so I'm gonna stop here. That's all I have. I now I see there were some questions in the chat. So should I just continue answering
Oh,
the questions in the chat?
yeah, maybe I can step in here. Thank you so
Mhm.
much for the fantastic talk. This is the second time I listened to it, and I'm still learning something new. We have three questions from the audience. The first one is from Dr. Shin. Thank you for the great presentation. The idea of measuring economic development with satellite image and other images are interesting. In the result, I see you have measured population and gross floor area with the model. Have you tried measuring more complicated metrics, such as income level, education, poverty, and others?
That's a great question. So we didn't measure population and gross floor area. That's given by South Korean government. In South Korea, we had all this data. Uh, we are fortunate to have them so that we can use those as kind of like the evaluation criteria. Um, but I mean, your point is right. What we can do is we can try to create a partial order graph, like asking experts to create a partial order graph with the criteria of population density or income level. We can ask experts. I mean, before what we have done so far is ask them, please rank those clusters by level of economic development, as you see. But we can ask questions in more detail. Uh, can you rank these clusters by the order of income level of the residents living there, or any education or poverty level? So we can do that. But what we uh, found out is ranking these images by these specific measures will be extremely difficult. Just like by looking at those images, education level, of the people living in the specific at grid level region, it's gonna be really hard. So what we are thinking is now is we need kind of more information that can help experts to rank. So we want to bring in more data. I mean, it's another data problem, but we are thinking some ways of integrating more data to help experts rank these clustered images with other more detailed economic criteria. So we are working on that direction. So I think that's definitely what we need. The many demands are in that regard, in that direction.
Thank you.
Perfect. Well, maybe, I mean, going into that deeper in that much of a scale of data can be quite a challenge. So the study that you did, we can use it as sort of to identify the more interesting regions at the global scale, and then we can go into deeper for a specific set of the regions that is more attractive with the more detailed data at the local level. That may be another
That's
option.
right. That's right. That's right. That's right.
So the second question is from Cheng, Dr. Low. Thank you for the fascinating talk. How do you make sure that the comparisons between different models are fair enough as the image resolutions are different, and furthermore, the evaluation setup can also be different?
I think that's a fair question. It's a different setting, different countries, and different resolutions. So many things are different, but we are just saying, like the correlation between, I mean, the correlation over 70% is some target number that we want to achieve. So, I mean, it's just like not saying the other models are perform less good than others, but like just like we are aiming for over 70% correlation. So like as our technical brains, they are really focused. I'm not engineer, but our engineering brains, they really want to make the performance better. So it's a 70%, so more than 70%. And if it's over 80%, that'll be wonderful. And until we reach that point, they like revise their model and they write different loss function or different model parameters. So that's kind of like how we use those model evaluation of the other work.
Mhm.
Thank you for the
Okay, our
question.
last question is from Dr. Namu Kim. Thank you for an interesting presentation. I have a couple of questions. Number one, in slide 8, it appears that the area with fewer green or yellow regions in the partially ordered graph have been assigned slightly lower ranks. Without the involvement of local experts, what do you think about the prediction result obtained using the partially ordered graph generated based on the ratio of green and yellow regions?
I'll answer this first. Yeah, I'll answer this first. So for let's see, I'm not sure this will answer the question. At the clustering stage, we grade all the images. So we don't give any color information to the clustering algorithms. But when we do partial order graph, we give experts the colored versions of the images. I don't know how it impacts the POG. That's an interesting question. Um, hmm. So yeah, green and yellow regions. So another thing, what's interesting about these satellite images is so we get this free satellite images annual in the annual sense. We don't really, because it's free, we don't get it in a very frequent time frame. So we get one image for a year, but then this image is not really one an image at the same timestamp. But what the engineers behind the satellite images do is they kind of see multiple images and they kind of like aggregate them in to make one image where there is cloud free and the weather must be, weather must be clear. So it has to be like it's like puzzling in with many different time steps to create uh that ears um that ears satellite image. So it's if we had more clear images in the fall, we are likely to have more yellowish images. But in certain year, if it was summer, images were so good, and then maybe it was a summary images were the images for this specific region, it'll be greener. So it has this inconsistency and for time-wise, it's time inconsistency in the quality of satellite images. So this is what makes this problem a little bit more difficult, and that's why we kind of like grade our images for the clustering algorithms. So this is definitely a challenge that we need to work on more. Yeah, I think that was a really good catch.
Great. Second question from Namu is that you mentioned using satellite images from 2016 to 2019 in a North Korea study. And I'm curious if changes in urban areas, such as development, are visually noticeable over the course of approximately 3 years. Further, I'd like to know the professor's perspective on the significance of researches that utilize deep learning to observe such changes.
So that's a really good question. So as I showed, there were some regions where the changes were really noticeable. This is what I showed. Sorry. Did I show? Nowhere. Oh, yeah, here. No, did I? Yeah, here. So in the first row, you can the changes are visual. The visible just by bare eyes, right? And no changes here. So it's so there were much going on over the 3 years, surprisingly. But if you just look around KAIST campus, like there are many constructions going on. If we take the satellite images of KAIST next year, many things will change. So there's like for the active economy, you can see those changes. And my perspective on the significance of machine learning, deep learning, it's great. It is great. So I'm an economist. Economics is maybe the most. This is gonna be on YouTube, so I have to be careful. But economics is the most traditional and most conservative academic discipline. Even so, we are very slow in changes. We are very slow in adapting to the new changes and new technologies. And even in this economic discipline, more and more people are interested in using deep learning. Like from like 5 to 6 or 7 years ago. It's been a new wave. So we're gonna see more of utilizing deep learning even in many not in engineering but also in social science for sure. Humanities I'm not so sure, but social science for sure.
Great.
Thank you.
Okay.
Our question number 4 is from Kwang Song. Is there any other research or idea where the model is trained using images without relying on the expert labeling? That's a big question.
Yeah. So our technical brains are not here. I asked a very similar question to our technical brains, our computer science students, a couple of weeks ago, and they said no. Without relying on any data. There are many papers that came up with machine learning algorithms using existing survey data. But expert labeling, I think we are the only, in the context of satellite images, I think we are the only work so far. And for the models that cannot be applied to this few economic data, I think we are very unique in that sense.
Mhm.
That was possible because when we started this work in like 5 years ago, our main motivation of this study was studying North Korea. So that was our main motivation, and that's how we came up with this model. And we think this is the only model that can be applied to those few economic data regions.
Mhm. Yeah, I have to agree with Professor Kim. I mean, considering how scarce the data is for North Korea, this is fantastic approach. You're just using sort of like a general set of the satellite image. Our last question is from Haeyoung Lee. I have one question. What should we consider when we try to apply the same model to other developing countries? Because I think the shape of the CPOC will vary depending on the shape of the city in each country.
That's a really good observation. So the weakness of our approach is we think we have to apply this model country by country. Like we cannot really, I mean, we can try, we can train our model to North Korea, and we can use that model to generate scores for other countries. I think we tried it. Do we have? I think we tried it, but the performance wasn't really good. I don't know. We can improve upon that front, but we are not there yet. So because as you said, as Haeyoung said, it's every country has their uniqueness and their development, like how they construct their villages. When villages are created organically or they grow organically, and also depending on their weather and climate, like when you look at those villages from the above, they have very different styles over different regions. So we have to create this POG by country, I think, to get a the good performance. So for each country, we can group them, maybe like 2 or 3 countries if we think those are very similar, they share similar patterns in development, we may group them and create a POG. But I don't think we can kind of like create a POG with South Korea and African countries kind of together. I mean, that's gonna be a little bit hard. So like global scale, the model, they can work for global scale comparisons. That's something that we need to work on more. Okay.
All right, we covered all the questions and we almost run out of time. Thank you again so much, Jihee, for coming and sharing your fantastic research with us. And thank you everyone for coming and attending the seminar. Jihee, do you have anything to add before we wrap up? Oh, okay, that's great. Thank you so much. Have a fantastic weekend.
Have a good weekend. Bye
Thank
bye.
you.
고생 감사합니다.
네, 감사합니다. 들어가세요.